Hi guys, it's Miss Hill here again, and we're continuing talking about systems of equations. Today we're going to look at the applications, or in other words, we're going to be looking at word problems for systems of equations. So with each of these, we're going to want to follow the same steps. First thing we're going to want to do is define our variables. What is x going to represent? What is y going to represent? Always define your variables. Then from there, we're going to write our equations. And then we will solve our system of equations using whichever of the methods that you prefer. I'm going to be solving them algebraically using either the substitution or elimination methods. If you choose to prefer to switch everything over to slope-intercept form and graph them on your graphing calculator, totally fine with me as long as I can see that you have defined your variables, written your equations, and you've come up with the solutions. And don't forget to check those solutions. Make sure that they actually work. So let's look at our first example here, where we have the sum of two numbers is 26. The larger is 7 less than twice the smaller. We want to find the numbers. And yes, we are giving you the answer here that we should come up with 11 and 15, kind of helping you out with these practice problems. But let's go back. We're talking about the sum of two numbers. So we know that we have two numbers. So we're just going to say that x is that first number, defining our variables. And y is going to be the second number. So we have defined our variables. Now from here, we're going to write our two equations. So the sum of those two numbers is 26. So that means that x plus y is equal to 26. Then for the second equation, they tell us that the larger is 7 less than twice the smaller. So if the larger number is 7 less than twice the smaller, then we can say, well, if the first one is the larger number and the second is going to be the smaller, we can be more specific with defining our variables. Then we can say that the larger number x is 7 less than twice the smaller. So we're going to subtract 7 from 2y, or the smaller number. So now we have our two equations. Well, since we know that x is equal to that 2y minus 7, I'm going to use substitution method and say that 2y minus 7 plus y, there's our x from that first equation, and that's equal to 26. So now I can go and combine like term solving for y. So I'm going to have 3y minus 7 equals 26. Adding 7 to both sides, I'm going to have 3y is equal to 33. Dividing both sides by 3, I have y is equal to 11. Now that I have my value for y, I can plug that into, and I'm going to use the second equation and say that x is equal to 2 times y, which was 11, minus 7. So that means that x is 22 minus 7, which is simply going to be 15. So did I get those two values that we said? Yes. We have 15 and 11. So there's x and there is y. And again, we can go back and check, does our answer make sense in both equations? Well, 15 plus 11, x plus y, that does equal 26, so that does work. And we can check the second equation, do I get 15 when I say 2 times 11, which is 22 minus 7? Yes, I do. So that means that I am correct with saying that my first number, or the larger number, is 15, and my second number, which is a smaller number, is 11. All right, let's try another one. For number 2, we have the difference of two numbers is 32. Their sum is 13 less than 5 times the second number. We want to find those numbers. So again, we're talking about two numbers. So defining our variables, we're just going to say that x is the first number and y is our second number. So looking to see what are we going to do with those variables, writing our equations. The difference So we're going to subtract our two numbers and get 37. So x minus y, or sorry, not 37, but 32. So x minus y is 32. And then in our second equation, the second sentence tells us that their sum is 13 less than 5 times the second number. So look at those two parts. The sum is, so x plus y is, there's our equal sign, 13 less than 5 times the second number. So 5 times the second number, which was y, we want 13 less, or 13 subtracted from that product. So we have x plus y equals 5y minus 13. Well, this is one that we could kind of move things around and solve using elimination, or we can take one of our equations, we can take that first equation and solve it for one of our variables and use the substitution method. And that's what I'm going to choose to do here. Looking at our first equation, since I have x with the coefficient of 1, I'm simply going to write that as x equals 32 plus y. And then I'm going to substitute that in here to the second equation. So I'm going to have my x is 32 plus y. And then plus y equals 5y minus 13. So now I can combine like terms and see that I have 32 plus 2y is equal to 5y minus 13. I can get my variables to one side, subtracting the 2y. I have 3y. And then adding the 13 to both sides. 13 and 32, that's going to give me 45. So if I have 45 is equal to 3y, dividing both sides by 3, that's going to tell me that y is 15. So I'm going to take that value and substitute it in. I'm going to go back to that first equation of x minus y equals 32. Their difference is 32. So x minus 15 is equal to 32. So when I add 15 to both sides, x is going to be equal to 47. So there's my solution. That first number, we can write it right here, was 47. And my second number was 15. Or you can write it as the ordered pair, 47, 15. And again, going back and checking, it does work. We can say our 47 plus the 15, that is going to be equal to 5 times that 15 minus 13. It does work for both equations. All right, so those are two examples using the sum and difference of two numbers. Define which number is the first one, which the second one, which one's bigger, which one's smaller, based on the problem and what's given, what's being asked. The other type of problems that are used frequently with systems of equations are talking about perimeter or maybe area. So keeping in mind when we see something like the perimeter of a rectangle is 64 feet, the length is 13 feet less than twice the width. We want to find the dimensions. So we're looking for the length and the width. So that's giving us the idea of what variables are going to be used in the equation. So we're going to say L is our length and W is the width. And then we also want to keep in mind, since we're talking about perimeter of a rectangle, we can use perimeters 2LW, length and width. So 2 times the length plus 2 times the width. Thinking of a different formula there. So if they're telling us that the perimeter is 64 feet, I'll switch colors there, we can write that equation as P is 64. We know that. Then they're also telling us that the length is 13 feet less than twice the width. So our length is 13 feet less than, or 13 subtracted from, twice the width. So we have L equals 2W minus 13. So if our perimeter is 64, we're kind of substituting both of these into that perimeter formula. So we're going to have our perimeter of 64 is equal to 2 times the length, which we said our length was 2W minus 13, plus 2 times the width, so plus 2W. So here we'll use some distributive property. 64 is going to be equal to 4W minus 26 plus 2W. Combining like terms, 64 is equal to 6W minus 26. And then from here, we can add that 26 to both sides, and that's going to give us 90 is equal to 6W. And then 90 divided by 6, that's telling us that we have a width of 15, and this was in feet. So 15 feet would be our width. And then from here, we want to find the length. So we're going to have to substitute that back in. So remember we said the perimeter of the whole thing was 64. So 2 times the length plus 2 times our width of 15. We can substitute that in. So here we'll have 64 is equal to 2L plus 30. Subtract our 30 from both sides, and we have 34 is equal to 2 times the length. Dividing both sides by 2, and that will tell us that our length is 17 feet. So there are the dimensions for our rectangle, 15 and 17 feet. All right, moving right along. Another popular type of problem for applying our systems of equations is talking about money. And who doesn't like to talk about money? So if we have Sue with a collection of quarters and nickels, she has 17 coins whose total value is $1.85. We want to figure out how many type of each coin that she has. So again, first thing we want to do is define our variables. So we can say that quarters are Q and N are nickels. So Q is the number of quarters, where N is the number of nickels. And they tell us that she has 17 coins. So we know one of our equations is going to be, not X, we used Q, plus N is equal to 17. There's her 17 coins. And then the total value is $1.85. Well, if we remember that quarters are worth 25 cents, so 0.25, 25 cents per quarter, plus nickels are 5 cents, so 0.05 N is equal to that total amount of $1.85. And again, here you can use either method that you want. It doesn't matter if you use substitution or elimination. I'm choosing to use the substitution method. I'm going to take this first equation and I'm going to find the number of quarters first. So I'm going to say that Q is equal to 17 minus N. And this is what I'm going to substitute in to that second equation and say my 25 hundredths times 17 minus N plus our 5/10 N. Make sure you can see that decimal point there is equal to the $1.85. Okay, so multiplying through using that distributive property, our 25 cents times 17, plug that into that lovely calculator, and we get 4 25/100ths, or we have $4.25 in quarters, minus N, or whoops, not minus, just plain old N, 0.25 N. Don't forget to distribute, plus our nickels, so 5 cents per nickel equals $1.85. Then we can combine like terms, and I'm going to do everything in one step here to save some space. But our negative 25 hundredths in plus that 5 hundredths in, we're left with our negative 2/10 in. And then subtracting that $4.25 from both sides, that's going to leave us at negative 2 4/10. There we go. So now when we divide both sides by that negative 2/10, then we can see that n is going to be 12. So that means that we have 12 nickels. And then we can go back to that first equation. Q plus N, which we just found was 12, equals 17. So that means that we have 5 quarters. And again, plugging in the value for each of those coins, then we'll see that our 25 hundredths times 5 plus our 5 hundredths times 12 does come up to that $1.85. So we found the correct number of each coin. Right, so our money problems don't have to relate to finding how many coins there are, how many of each different type of coin. We can look at the number of tickets sold and the type of tickets. You know, you go to the movies and you can buy an adult ticket or a child's ticket. So let's look at number 5 here. A certain movie theater has a capacity of 250 people. A child's ticket costs $3, an adult movie ticket costs $450. A full house last night, maybe they went to see Star Wars, made $1,017. How many children and adults attended the movie? All right, so we're looking at 2 different types of tickets. So we have the adults and the children. So if we say that A is the adults, so we'll say number of adults. And then we'll say that C is the number of children. Now they're telling us that we had a full house, so that means that they sold all 250 of those tickets. So there's our first equation, that A plus C is equal to 250. Then we can look at the cost of each with how much they made, that second equation. So if a child's ticket cost $3, an adult ticket cost $450, and they made a total of $1,017, then that means our second equation is going to be that $450 per adult. So $450A plus 3C, $3 per each child's ticket, is equal to $1,017. So here we can use elimination, we could use substitution. We haven't used elimination yet, so let's use that one. I'm going to take my first equation and multiply everything by, let's make everything here equal to a -3. And why am I doing that? Because I have a positive 3C where I have a positive C up top, and when I distribute that -3 to everything, then that's going to give me -3A minus 3C is equal to, and that would give me -750. And then bringing my second equation over, we have our 450A plus 3C is equal to 1,017. So now when I go to eliminate my -3C and positive 3C, they're gone. Then combining my -3A with the positive 450A, that leaves me with 1 5/10 A. And on the other side, my -750 and my 1,017, that's going to leave me with 267. And then dividing both sides by the 1 5/10, I can see the number of adult tickets sold was 178. So there's that one, my number of adults was 178 adult tickets. And then we're going to use that first equation to figure out how many of the children's tickets were sold. So A plus C equals 250. So that 178 plus C equals 250. Subtracting our 178 from both sides, we can find that there were only 72 of the children's tickets sold. So an easy way to figure things out and kind of double check records if you're working in that industry and see, did our calculations come out correct? All right, one more, and then we'll talk about some special circumstances. Oops. Let's see if I can get this back up here. There we go. Let's look at number 6, where we're talking about apples and bananas. So if we have apples that cost 6 cents while bananas cost 4 cents, Bob bought several pieces of fruit for 70 cents. He spent 34 cents more for bananas than apples. So how many of each did he buy? So if we're talking about apples and bananas, then we can easily say that A is for apples, or the number of apples that he bought, and B would be for the number of bananas. So keeping in mind that first sentence here is going to tell us that the apples cost 6 cents, bananas are 4 cents. And he bought several pieces of fruit for 70 cents. So there's his total cost. So 6 cents, or 600ths A for the apples, plus 4 cents, or 400ths B for the bananas. And that total cost was 70 cents. And if you want to get rid of decimals, I'll just kind of throw this idea out there. If you multiply everything by 100, then we can get rid of those decimals and talk about 6 cents for every apple plus 4 cents for every banana is equal to 70 cents. So if we're putting everything in terms of cents, then we can just multiply by 100 and we don't have to worry about the decimals. And then we can use that same thought process with that last equation. He spent 34 cents more for bananas than for apples. So spending 34 cents more, then we can say what he what he spent for apples. Let's see, where are we writing this here? Sorry, I lost my train of thought for a second here. We can say that whatever he spent for the apples, 30 cents. So what he spent for bananas, there we go. He spent 34 cents more than apples. So 34 plus A. There we go. Okay. So we can use either one. It doesn't matter which method we use here. The cost of bananas was 34 cents more than what he spent for the apples. So if bananas were 4 cents and apples were 6 cents, then we can say 6A plus 34, there we go, is equal to 4B. And I'm going to use this equation here. I'm going to bring that down. We're going to forget the one with decimals and say that 6A plus 4B equals 70. So what I'm going to do is simply use the elimination method and say that if I kind of move things around here a little bit, let's see, and say if we have a negative, I'm going to bring this over here, so negative 6a plus, 4b equals 34. So they're both in similar forms. I'm going to take this and we'll be able to see that we can eliminate. Negative 6a plus 4b is equal to 34. That equal sign didn't really show up there. There we go. So now when I go to eliminate, the 6a's are gone, and we have 8b is equal to 104. So then b is equal to 104 divided by 8 would give us 13 bananas. And then we can go back to that first equation. 6a plus 4 times our b value, which was 13, equals 70. So 4 times 13, that would give us 52. Subtracting our 52 from both sides, that's going to leave us with 18. And then dividing both sides by 3, we can see that a is equal to 3. So that means that the number of apples is equal to 3. And we can plug that into both equations and it will check out. So we have 3 apples and 13 bananas that we bought for 70 cents. All right, now another method or another scenario where you're going to use system of equations is with wind and current problems. So keep in mind any type of wind and current problem, we can set them up the exact same way every single time and we know that we'll get them right. So if you always let x be the speed of the boat or the plane in still water or air, and then let the y value be the speed of the current or the wind, then it's easy to define your variables. And then keep in mind x plus y is when you're moving with the wind or the current, and x minus y is when you're moving against the wind or the current. It's going to slow you down. You're going to move at a slower rate. So if we're talking about a plane that's flying with the tailwind, so with the tailwind, it's moving with the wind. It's kind of pushing you along. A light plane can fly 720 miles in 2 hours. Going against the wind, so we have that wind kind of slowing us down. Our plane can fly the same distance, that same 720 miles in 3 hours. So we want to find the speed of the plane and the wind. So remember we said that x is always going to be the speed of the plane, and then y is always going to be the speed of the wind. Every single time. And then keep in mind when we're talking about speed, we'll make note of this over here, that our rate or the speed is equal to distance divided by time. So if we're talking about moving with the wind, or when we have the tailwind, then we can say that x plus y is equal to that 720 divided by 2. Or x plus y is going to be equal to 360. Then that return trip going against the wind, we have the headwind. Then we have x minus y is equal to 720 divided by the 3 hours that it takes. Well, 720 divided by 3 is going to be 240. Now here's what I like about these type problems. They are automatically set up for you to solve by using elimination. So we can see right here with x plus y and x minus y, the y's eliminate, and I have 2x is going to be equal to 600. So that means that when we divide by 2, x is going to be 300. So that means that the rate of the plane is 300 miles per hour. And then to find the rate of the wind, you can choose whichever one you want to substitute it back into. But I'm going to go with the first one. 300 plus y is equal to 360. So we subtract the 300 from both sides and we can see that the rate of the wind is 60 miles per hour. So set them up the exact same way every time. X is the speed of the plane or the boat, y is the speed of the wind. X plus y is when you're going with the wind or with the current, and x minus y is when you're going against the wind or against the current. So we'll do one more of these and then we'll be done for the day. We're going to talk about our boat. So we have our plane example, the boat example. We have our boat going upstream at the rate of 14 miles per hour, and it can return traveling downstream at a rate of 30 miles per hour. We want to find the rate of both the boat and the current. So again, x is always going to be the speed of the boat. And then y is also always going to be the speed of the current. Every single time, that will not change. So if we're going upstream, upstream is when you're going against the current. Downstream is when you're going with the current. So if we're going upstream at 14 miles per hour, so against the current, that's our x minus y. They gave us the rate, so we don't have to say our distance divided by time. They already did that for us. So that 14 miles per hour, they already said our distance divided by time. So that saves us a step there. And then returning, the return trip downstream, so this is with the current here, at a rate of 20 miles per hour. So that's x plus y is equal to 20. So just read carefully to see the order that they're giving us the information. So once again, we're set up for that super quick and easy elimination method. And we have 2x is going to be equal to 34. Dividing both sides by 2, we have x is 17. So that means that our boat is moving at a rate or a speed of 17 miles per hour. And then we can substitute that back in. I'm going to use the second equation, x plus y equals 20. If x is 17, then that means that y is going to be equal to 3. So that means that the current is moving at 3 miles per hour. And there we go. If we plug that back into both equations, you'll see that it works. So our boat is 17 miles per hour and the current is moving at a speed of 3 miles per hour. Don't forget to do all of your homework and check your answers on Blackboard. Email or send me a remind message if you have any questions, and I will see you in class. Bye.